Hi everyone, my name is Emily Gibson. I recently joined an accelerator program by Starter, where we're working on AI and ML related projects, and this project is one of them. In this project, I work with a US banking dataset for creating a customer churn prediction system. So the goal of the project is to identify customers who are likely to leave the bank and support early retention strategies. So for this project, I used a publicly available bank customer dataset from Kaggle. The dataset includes features such as credit score, geography, tenure, and whether the customer exited or not. The machine learning pipeline of this project consists of data cleaning, pre-processing, feature engineering. The data was split into training and test sets. Then the class imbalance was handled using Smode. And then I trained these baseline models using classical machine learning models um, such as XGBoost, KNN, logistic regression, random forest, SVM, etc. And since this is a churn prediction problem, a recall was chosen as the primary evaluation metric. And it's important than accuracy here because seeing a customer who will churn is more costly than incorrectly flagging a loyal customer. And hence keeping that in mind, I did the hyperparameter tuning, which I performed on the XGBoost model. Just a minute here. Here it is. Which I performed on the XGBoost model using a grid search CV. And this improved the recall and overall model performance. All right. And then finally, I deployed the model as a Streamlit web app on Render, which is a cloud application platform. All right. So this web app allows users, let's say a manager of a bank, who can view customer details, the attributes of a customer, like the customer ID, name, credit score, location, number of products they've purchased. So once you choose a customer, let me actually choose a customer, say Bon. Once you choose a customer, a God chart shows the churn probability. So the churn probability for this particular customer is 28.2%, which is particularly less. So let me choose another one actually, which one might have a higher probability of churn. Yes, Onio has a really high probability of churning, 68.9%. And there's also a bar chart shown the churn bar chart showing the churn probability by model, the estimated customer lifetime value, the customer probability of churning. I've also added a customer percentile section where the percentile is shown according to the matrix of the customer, and then an generative AI generated explanation of prediction, like why as to why the customer is like how as to why the customer is going to churn or not churn. And here a lot of metrics are also included, like the customer profile suggests they may be at risk of leaving the bank due to several factors, like it's a female customer with 3 products, which corresponds with being above the median number of products among churn customers. Additionally, our balance is significantly higher than the median balance among non-churned customers. These factors indicate that Unio has a diverse set of products, which may be indicative of a more nuanced financial situation. On the other hand, Unio's age and tenure are not particularly concerning indicators of churn. Yeah, so these explanations overall are all generated by an LLM or a large language model. And then finally, an AI-based retention email for the customer using generative AI like so. And that's it. So this project actually demonstrates an end-to-end machine learning workflow from data pre-processing to model tuning to deployment, all in one as a live web application. I hope you guys enjoyed my project demonstration. See you in the next one. Bye.